The focus of this video will be on renewable energy-related technologies. You might remember the importance of the three-steps approach, or trias energetica, which also connects to an optimized implementation strategy related to scale. The first step of reducing demand will be quite obvious. But how could one find out the potentials of step 2, reuse, and renewables, step 3, in an urban area? And how will this lead to the right matches and solutions? Here comes in the opportunities of geo-information systems, amongst others. Shown here is the project in West Holland. By mapping the different potentials, both existing for reuse as well as related to renewable energy generation connected to its exact geographical location, this is also known as energy potential mapping. Energy potential mapping and the quantification and creation of a so-called stack of all these separated and mapped potentials related to location provides opportunities to connect them to spatial changes and plans. Decision support for both urban planners, designers and municipalities or public utility companies can thus be provided. They, on their turn, can better tune demand and supply in new plans or in urban retrofit plans, resulting in the creation of new, innovative, often hybrid solutions with energy microgrids that match and optimize supply and demand and are based on renewables. Such systems not only include a changed network approach, but also new integrated concepts, like parked electrical vehicles, used for the temporal storage of electricity, but also wastewater-based concepts to recover nutrients and energy, for instance, via anaerobic treatment, creating biogas to be used for heat and/or electricity. Next is, of course, the question how we could include these systems of energy generation and storage in our buildings, infrastructures and living environments. The most obvious way is to integrate it on available, redundant spaces, like on our roofs and other available surfaces. But often there is a lack of sufficient optimized space to do so. So we need to be creative and both optimize surfaces as well as locate generation of electricity nearer to the actual use or demand of energy. Another option is to combine it with other functions, like shown here with solar shading devices in facades. But often it can also involve integration into building or infrastructure surfaces. This of course means that generation of energy is not always maximized or optimized according to orientation. This is not necessarily a problem, as long as you include this in your calculations and in your total energy plan. Indicated here are reductions in solar energy generation due to these different orientations. Please note that the numbers mentioned here are specific for northwestern Europe. Each geographical location around the world, or so-called genius loci, will have its own specific numbers. But once you look at the opportunities for integration, whole new worlds will open. Like shown here, for example, the modular system of Indiegogo solar roadways. Integration is a challenge and will be different for different urban morphologies, be it either in low density and new environments, or with high-rise and/or existing environments, or in compact and integrated environments, like shown here. In the end, it is up to your own creativity how to include such technologies, be it green, blue or energy related, in the living environments while optimizing synthesis of the different aspects.